Let's see how to differentiate f of x equals to square root of x from first principles. Now, a quick reminder, when we differentiate a function from first principles, we really go back to the definition of a derivative. And that is that f dash of x is equal to the limit as h tends towards 0 of f of x plus h minus f of x over h. So, since in this case f of x equals to square root of x, this will be equal to the limit, as h tends towards 0, of the square root of x plus h minus the square root of x over h. Now, at this stage we're sort of stuck. We're kind of brought to a halt. But there's a nice little trick that we can use here. We're going to use the fact that if we multiply a minus b times a plus b, that's equal to a squared minus b squared. Now, if you're studying calculus, you'll have learned this formula, the difference of two squares, years ago. But here's how it can still come in handy. We are going to write this. F dash of x is going to be equal to the limit, as h tends towards 0, of the square root of x plus h minus the square root of x, all of that over h, times the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. Now, we're allowed to do this because this second fraction here is obviously just equal to 1. So we're not changing anything by writing this, we're just using a little trick. When we multiply those two numerators together, each of those terms is going to be squared. And we're basically faced with the same scenario as we had above, a minus b times a plus b, with the exception that in this case, a is square root of x plus h, and b is square root of x. So using that formula, we can now write that this is equal to the limit, as h tends towards 0, of x plus h minus x. The denominator will become h times, open up the parentheses, the square root of x plus h plus the square root of x. Now that numerator is going to simplify a bit to lead to h on the numerator, and on the denominator we'll still have h times the square root of x plus h plus the square root of x. Those h's will simplify, and leaving us with the limit as h tends towards 0 of 1 over the square root of x plus h plus the square root of x. Now, if we carry on below, we can see that, I'll just rewrite that, it's getting a bit crunched up there. We can see that this is equal to the square root of x plus h plus the square root of x. Now in the limit, as h tends towards 0, this is going to lead us to 1 over the square root of x plus the square root of x. In other words, f dash of x is equal to 1 over 2 root x. And we're done. And that's how you differentiate the square root function from first principles.